What happens when you let engineers have completely free rein? No regulations, no power limits, and whatever mad aero designs they can come up with. Well, you get crazy powerful, high downforce monsters. This is exactly what they do in the Unlimited division at Pikes Peak, where we get to see how they stack up against each other, as well as how it can go wrong. Home designed and made machines can compete against big money international car companies to race to the top of the 14,000 foot mountain. A course with no runoff, no barriers, standard road tarmac and 2,000 foot drops. The Unlimited division is like nothing else in motorsport. Taking a look at the regulations, they say as long as you conform to the regular safety rules, you can do anything you like. As much power as you want, any design and as much downforce as you can create. As long as you have a roll cage, harnesses, helmet and other standard safety features, you're good to go. This leads to some extremely fast cars, and yet all of them are very different. So what does it take to take the record at Pikes Peak? How quick is it possible to go with no rules? Pikes Peak is a public highway where back in 1916 people began competing with their cars. The tight, twisty road climbs up the Rocky Mountains in Colorado and finishes at over 14,000 feet. Nowadays the dirt track has been paved, and this has led to faster and faster times. However, it's no less tricky to drive. The mountain is often snow covered in the winter and reaches soaring temperatures in the summer, which can cause the tarmac to warp and become very bumpy. There are no barriers either, so many of the turns have a 2,000 foot drop only a couple of feet away. The elevation can also really affect the driver, leading to reduced mental function and dizziness. So many of the drivers have oxygen pumped directly into their helmets to stay sharp. Most race series have tight technical regulations to keep the racing close. However, at Pikes Peak they take the opposite approach. They let physics define the pace and give the competitors free rein over their designs. So what engineering tricks do they use to be quick in the race to the clouds? Firstly, the power to weight ratio is everything here. The combination of very sharp hairpins, heavy acceleration zones and the incline of the course mean the maximum power for the minimum weight is the answer to quicker times. I've actually done a few hill climbs before, and lots of the run time is in the acceleration zones, in the exits of the corners, in order to carry the momentum up the hill. You will see that the majority of the cars have small 4 or 6 cylinder engines with at least one turbocharger, if not two. This creates more power for less weight, but also solves another big problem that the designers face. Due to the extreme elevation, the air is much thinner at the top of the course, meaning that naturally aspirated engines can lose as much as 30% of their power when they get to the top, due to there being less oxygen for the engine to use when burning fuel. Fitting turbochargers can reduce this effect. Mechanically forcing the air into the cylinders can keep the engine working effectively as the air is at a higher pressure, giving the engine enough oxygen to run. Next on the shopping list for these cars is downforce, and lots of it. This course has a much lower average speed than normal race circuits. This, along with lower air pressure, means the cars need very large wings to create the immense downforce needed for a quick time. If you think about it, at altitude there are fewer air molecules hitting the wings. This leads to a lower mass of air being forced upwards and less downforce on the car. So the designers use the largest wings possible, as well as many smaller winglets on the car's body, enabling high downforce even at lower speeds or higher altitude. There is also the opportunity to add features that are banned in more conventional race series. Things like skirts to seal off the floor of the car. These create a very low pressure area under the car, literally sucking it down into the tarmac. Or even active aero. You could automatically adjust the wing angle to reduce drag on the straights or increase downforce on one side of the car during cornering to increase grip. Potentially, you could even go full Adrian Newey and have a fan on the underside of the car, sucking the car to the ground for downforce even at very low speeds, similar to the virtual Red Bull X 2010. Gaining elevation quickly requires a lot of power, but thankfully the Unlimited class has no restrictions on the engine or modifications you can make to them, so many of the cars in this class produce more than 1,000 brake horsepower. You will also notice that most of the cars that do well here are built on very short wheelbases, allowing them to rotate the car in the slower turns, making the car more nimble and ultimately faster over the run. However, with a shorter wheelbase, the car will become more unstable in the quicker corners. This is Paul Dallenbach. He's got 6 class wins and held the overall record in 1993. And this is the PVA 03, a car that he designed and built himself. It's got a custom-made carbon fibre chassis and is fitted with a 25-year-old IndyCar engine that originally produced 750 horsepower. But with the twin turbochargers, it now produces nearly 1400 horsepower. You will have noticed the size of the front and rear wing. The sheer surface area and wing angle creates massive downforce. This is supported by a lot of other bodywork features used to produce many little performance benefits. But in 2012, Dallenbach showed just how dangerous the racing can be at Pikes Peak. Less than 30 seconds into his final run, he pulled 5th gear in a fast section of the track and the throttle jammed wide open, sending him into the trees at 130 miles an hour. He hit the brakes, but nothing would stop the 1,400 horsepower engine at full chat. The car was sent flying straight into the trees, uprooting 2 of them and stopping Dallenbach almost instantly. Thankfully, the roll cage, hands device and crash structure worked perfectly to leave Paul with nothing more than bruises. If you've watched a few of these videos, please do check to see if you're subscribed. YouTube tells us that 82% of you aren't, and we'd love you to join. Another interesting member of the Ultimate class is much higher budget. Peugeot, along with sponsorship from Red Bull, created a specially modified version of their 208 rally car and set the Pikes Peak record with Sebastian Loeb at the wheel. It used a very light space frame chassis and had a 3.2 litre twin turbo engine that was mounted in the middle of the car. It was extremely light at just 875 kilograms and produced 875 horsepower for the magical power to weight ratio of 1:1. It actually shared many of its components with the Le Mans winning Peugeot 908 HDI, things like the rear wing, suspension components and enormous carbon ceramic brakes. The extremely short wheelbase and four-wheel drive meant the car could rotate well around the short corners and put the power down effectively in the traction zones. This all meant that Loeb could achieve an average speed of 87 miles an hour over his run. The car had massive downforce. The floor was similar to its LMP1 counterpart and produced more than 50% of the car's downforce. The enormous rear wing was fitted with massive end plates for better efficiency, and the front of the car was fitted with a massive splitter. Loeb was right on the limit through every one of the 156 turns and is unbelievable to watch as he smashes the previous record by over a minute and a half. VW are among many of the large car manufacturers to have a go at beating Loeb's all-time record. They took a very different approach and used all-electric power. This makes perfect sense at Pikes Peak. Maximum torque and no reduction in power with the reduced oxygen at altitude. So in 2018, VW created the I.D.R, a car that looks more similar to the 919 EVA that we spoke about in a previous video. It had an enormous electric motor powering each axle for a full four-wheel drive system. It had a torque vectoring system that allowed the car to sense the amount of grip on each tyre throughout the run and deliver the perfect amount of power to each wheel for perfect traction. This all meant that the I.D.R was faster to 60 miles an hour than an F1 car. The car took a similar design philosophy to something like an LMP1 car. It had a very streamlined body with an enormous rear wing and massive front splitter. The rear wing is mounted a long way off the rear of the car for more leverage over the rear wheels, leading to more force pushing the rear wheels into the track surface. The car also had very large skirts that you can see here, again to seal off the floor and create more downforce. Despite only one run on race day, it absolutely smashed Loeb's record by over a minute, with a time of 7 minutes and 57 seconds. The driver explained that he had to drive very differently through the fast-changing conditions on the run. Up to the cloud line he could push, but when he hit the cloud line, the track temperature was much lower. This meant that he had to back off to the lower grip levels. After losing about 5 seconds, he cleared the cloud line and the track was much warmer. So he pushed again, going 15 seconds faster than Loeb in this section. You should watch this video I made about the amazing Porsche 919 Evo, another car that didn't need to conform to a rule book. Thanks for watching and I'll see you next time.